Good evening, everybody. So the purpose of today's meeting is to go over running k-means clustering method in R, and this meeting is going to be recorded. So here is today's agenda. So we're going to discuss the data pre-processing, data preparation for the k-means clustering method. We're going to be running the method. We're going to be doing results interpretation, and we're going to do cluster-to-class comparison, and we're going to plot the clusters, and I'm going to be nice to you. The first bonus is going to be how to plot the square distances. The first plot is over here, right? So the first bonus is for attending WebEx or for watching the recording, and the second bonus is going to be for paying an undivided attention. And that's going to be, I'm going to show you a different method implementation where you don't need to specify the k value, and the method is going to estimate the k value for you. All right, so let's go ahead, and I'm going to share my screen. Share my screen. All right, and I want to be in RStudio. All right. So what we're going to do is I wrote a script in here, and we're going to be working here with the glass data set. And basically, what's happening is that the glass, based on the compound, right, based on the chemical composition, we're going to be trying to identify the similar glass samples, right? So what I'm going to do is I'm going to read the data I'm going to read my data into a variable. I'm going to call it glass. Now, you may have noticed that if you update the latest RStudio version, the option to read data from this interface is gone, okay? What you'll need to do is you either need to run the read CSV command, or you can use different import interface, but I'm going to show you if we have time left. All right? So now, the first line of code in here is that library cluster. If you have not installed this package, you need to install it, right? You need to install cluster package. Here, keep in mind that you would need to update your R version to 3.3.2, the latest R version, because when you install this package, it just by default, it's going to install from the latest version. And some of you may have received an error because make sure that you updated the R version, right? And you need this package for visualization, for the plots that we're going to do. So now, I have this package installed already, but since I restarted RStudio, I need to run it again. Yes, has anyone said something? Let me see. Somebody may have said something in the chat. Nope, nobody. All right. Anyway, so what I'm going to do is I'm going to go ahead and I'm going to run this command, right? So what it did was I loaded the library cluster. And here, what I'm doing here is that I'm setting the working directory, right? Set WD, that sets working directory. Now I'm going to read my data. And what I did here was it created the data frame and it called it glass, and it has 214 observations and 11 variables, right? And if you notice here, I have a glass type, right? But I'm not going to be doing classification in this lecture. I'm going to be doing clustering, right? So, first of all, let's preview the data. Run. So here it is, right? That's my data type. So basically, I have a glass ID, which is uniquely identifying the glass sample. And here is a chemical compound, right? And here is a glass type, right? So now what I'll do is I'm going to go back to my code in here, and I'm going to run the summary command. It's always a good idea to run the summary, right? So basically, we have 6 types of glass. Well, I'll show you in a minute. But what I'm going to do now, I'm going to run a table command on the type variable, just to see. So here it is. I have 6 types of glass. There is no type 4, right? And here it's showing me that I have I have 70 samples of the first type, 76 samples of the second type, 16 samples of the third type, and so on, right? Some of you asked me earlier, oh, some examples in the reading have even number, right? Even number. Here I don't have an even number, but that's fine because that's how my data is, right? So now what I'm gonna do is I'm going to create a copy of the data frame, and I'm gonna call it a new glass, right? New glass is going to be a copy of a glass. And let me run it, right? Here it is. So here I'm creating a copy. And the reason is because what I'll do is I'm going to remove the type variable. I'm going to remove the glass type variable because I want to group my glass samples. I want to group them, right, together, similar glass samples together without knowing what my class label is, right? So here I created a new glass. This is nothing but a copy right now. Now, my next step is I have to remove the unique identifier, right? And because unique identifier is just telling me the sample number, it does not affect what the glass is, right? It's not one of the properties of the glass. So let me run this. We set it to null, and keep in mind null is uppercase. Glass type, I'm going to set it to null also, right? The next command is I have to scale my data, right? So basically we have to standardize it, because if you notice it, each variable, right? Each variable has a different range. So what I'm going to do is I'm going to run the scale command in here, right? Now, next thing what I want to do is the method select the cluster centers at random, right? Since exercise might not be done in one sitting, right? I want to be able to reproduce the results, so that way I can get back to where I stopped. So what I'll do is I'm gonna do this. I'm gonna run this command, right? Now I'm gonna start running the method. I had several options here. I can just delete it or I can keep this, right? Let me delete. Here we go. So now, what I'm gonna do is I'm gonna run this method, and I'm gonna store the variable. I'm gonna store the results in the variable called KC, right? The first input parameter is a data frame name, which is a new glass. It's a copy of the data set, right? And I'm just gonna go ahead and I'm gonna just try 6 clusters. I'm gonna say, hey, wait a minute, I have 6 types of glass. Let's go ahead and try 6. Why not? I'm gonna run this. Now, there is no output. Some of you may remember I asked me, where is my output? I just ran the command. Well, it's because we store the output in a KC variable. Now what I'm gonna do is I'm gonna run KC, and it's gonna show me the output, right? Different component of an output. There we go. So now, the first part, it's telling me that I have 6 clusters. So in other words, my samples, I grouped my samples into 6 groups based on some similarity. And how do we determine what number of clusters? That's an excellent question, Emmanuel. We're gonna get to it. This is an excellent question. But before we do that, we need to discuss the rest of the concept, because they're leading questions. So if you notice that on a homework assignment, it's very important to do the questions in order, because the first question is leading to the second question. The first 2 questions are lead to the next question. So we need to understand the basic concepts, because this is leading to the number of clusters, and this is an open-ended question. But we're going to talk about it, definitely. So, I just decided 6. And the reason I chose 6 is because I have 6 types of glass. Is it a good choice? Probably not, but let's see what happens. And I have 6 clusters, and of course it's expected that the number of instances is different. Well, because, if you recall, right? I don't have an equal number of samples in each class, but, well, forget about class, right? Because it's an unsupervised learning. We don't have a label. We want to group the glass samples based on the chemical compound, right? So here, basically, cluster means it's going to be the average amount of each element, right? It's going to be, the cluster center is going to be the average. So what I'll do is I'm going to take all my samples in a group. I'm going to take all my samples in a group, and I'm going to measure for each element. I'm going to measure the amount, and I'm going to take the average, the mean, right? That's basically what it is. And here I take this element, and I'm going to take all samples in my group and take the mean, right? This is what I'm going to do here. So now 6 clusters means that I have 6 cluster centers. So there are going to be 6 points in a space. Think about it. Each center is a point in multidimensional space, right? So this is a center. And basically, what happens is that each sample, each glass sample, is assigned to the closest cluster center. Think about cluster center as a point, right? So here, basically, this section of the output, it's giving me the coordinates of each center, so to speak. I have 6 centers. Now, let's go down. Clustering vector. It's telling me in which group each glass sample falls into, right? So each instance in this data set is a glass sample. And here, the clustering vector, it's telling me here the first glass sample is cluster 6, right? The second glass sample is cluster 1, and so on, right? Now, here, this is important. This is a sum. For each cluster, we are taking the distance between, square distance between the center, cluster center, and the instance. So I was thinking about different ways to explain it, but let's look at the simple example. So here, let's look in the 2 dimensions how it works. So here is my cluster center A, right? And point B is my instance. How do I deal with this 2-dimensional? Remember, that's a Pythagorean theorem, right? So I'm going to take the difference between y coordinates, right? That's a base. I'm going to take the length of the base squared, right? See this? I'm going to take this difference, and I'm going to take this difference squared, and I'm going to add this, right? That's a hypotenuse. The square distance right here is the sum of these 2 square distances, right? The same thing is in multiple dimension, right? So here it's a Euclidean distance, right? Squared. That's a square distance, right? So basically, some of you asked me how that works, so I broke it down in 2 dimensions. We have something similar in multiple dimensions, right? And I'm doing it, I'm looking at each instance, right? And then I'm taking a sum for each cluster individually. Now, here, notice that here what it does is it's showing me different output components that are available. It's showing me different output components that I can look at. Because if you notice here, it only showed me the centers, it only showed me how many instances I have in each cluster. It showed me the centers, it showed me the clustering vector, it showed me this sum of squared, and that's it, right? But I want to know more. I want to look at the distance between centers of other clusters, right? I want to look at more. So what you could do is, remember the names command? You may have seen this command before, where you look at the names of the variables in the data set, right? But you can use this command for a different purpose. So here, my KC, it stores the output, right? So that's a list variable. It's a variable of type list. So I'm going to run names command. Here, it's going to show me different components of the output. right? It's going to show me different components of an output. So names command, remember, before you use this command to list the variable names, right? If I do this, remember it? Right, it's going to give me the variable names. Similarly, I can run names command to show the output components. So now I don't want to see the whole output, right? I want to see only the clusters. So what I do here, I do KC and I put a $sign and I put cluster, right? There we go. So that's going to be the clustering vector, right? For each glass sample, it's going to tell me the cluster number. Now I want to see only the centers. That's what I do, right? I just run centers, and I have 6 centers. Now I can look at the total distance, and I can look at the withiners. So we have several distances here. Do you remember this? So let's start from here. Here, I'm going to get the distances for every single cluster, right? I'm looking at these distances right here, right? I'm looking for each instance and I'm taking a sum, right? Here, that's what it is. Now, total withiness, it's going to be the sum of these numbers right here, right? So I'm going to run this command right here, right? So now, what we also need to consider is that we need to consider the distance between my instance and other cluster centers. So in other words, if my instance is in cluster 6, I want to look at the distance between the center of cluster 1, 2, 3, 4, and 5, right? So that's what it is, and I'm gonna do, here it is, the betweenness, this one, right? So we got this, and we also have the total distance, overall total, somewhere. Oh, it's here, TOSS, run. Here it is, so that's a sum, overall sum, right? Now, another component is the size. Size shows me how many instances are in each cluster. And in our case, instance is a data sample, is a glass sample. This part here is just showing you how many iterations the method ran. So basically, the method is iterative. On each iteration, each instance gets assigned to the closest cluster center, right? And the process continues until no reassignment occurs, right? And this one is basically used for diagnostic purposes, right? So 0 means no issues, right? So another thing what you could do is to learn more, what you need to do is run a question, put question mark, right, and put the command name. And I strongly recommend you to read the help page, because if you read the help page, it's going to tell you that what data pre-processing is needed. So make sure that your data does not have missing values, right? And you want to make sure that the data is numeric, right? It's going to show you here the method input parameters. So basically, you can specify the number of clusters, which is what I did, or you can specify the cluster samples. Or here, notice here, my method ran 4 times, and I can set the maximum. I can say, hey, for instance, no more than 10 iterations, and so on, right? I can I can change the input parameters. If I scroll down, over here, it's going to tell me what each output component does, right? So this is really nice. I would say help system is my friend, right? Now what I'm going to do is I'm going to compare. And what I'm comparing is that I want to see how my clustering method did with respect to clusters. Did it put the samples of the same glass type in the same cluster? Or what happened? Let's go ahead and take a look, right? So I'm going to do the table. It's a cross tabulation. I'm taking the cluster number. Remember this cluster? This is a vector, right? If you go up, if you go in the output, if you scroll up, basically cluster is this, right? So that's a vector. And for every element, it tells me the cluster, right? For each glass samples, it tells me the cluster number. So I want to see how the glass type matches the cluster, right? I want to see if the glass samples of the same type fell in the same cluster. That's what I basically want. So now I'm going to do the tabulation. But what is this? This is my original. Do you remember I took a copy? The new glass is a copy of the original, right? So what I want to do is I want to do the cross tabulation run, right? So now notice here, each row is a cluster, and here is a glass type. Now note that vast majority of glass type 1, right, about 2/3 actually, fell into the cluster 1, right? But cluster 1 is kind of like a mix. It has glass type 2, it has glass type 1, and it has glass type 3. Note that I'm having, well, initially I thought that 6 clusters is good, but take a look at this. See, I'm having some problems here. Well, cluster 4, I'm good, right? Because it clearly shows that the glass type 2. But let's look at here, cluster 5, I'm relatively fine, glass type 7. But here, cluster 1, I have a mix of things, right? I have a mix. So I could say my glass type 2 is dominant here. But the problem is, if I look at it, it's kind of like spread out, right? So my first cluster, I've got vast majority of class 2, of type 2, type 3. See this? This is basically what's happening. This is what you need to do in a homework assignment too. You need to compare you want to check if the instances, if the glass samples in this case of the same type fell in the same cluster, right? That's what you want to do. And now what I want to do is I want to visualize it. But now something to remember: in order to visualize it, you need to have the cluster package loaded into memory, right? So, but I did it already, so I'm ready to do this. I'm run this now here. And what I would like you to do is I would like you to run a help command on the cluster plot function to see the different options. There are options to show the labels, there are options to show the lines, or you don't want to show the lines. And I realize it's very difficult to see, so you can do the zoom, you can zoom in, right? It's very easier to see. And notice the overlaps, you have the overlaps, right? So this is your cluster visualization part, right? And what you need to do in an assignment, you need to explain what the plot shows, right? So now I'm going to go ahead and close this. Now I'm going to try k equals 3. And I just guessed it here, but you're going to see it later why, but I'm just guessing for right now. Just think about it. And start, I just want to start from the seed values that I set. Well, let's see. Let's run this command. So now I have 3, right? And let's do this. Let's do KC just to see what happened. I have 3 clusters. So my clustering vector, I have it 1 through 3, right? I have it 1 through 3 because I only picked 3. And I'm going to see 3 lines because I have 3 cluster centers, right? And remember, this is a chemical compound, so it's going to do some amount of each, right? It's going to do the amount, and it's going to be the cluster center. So now, and here are my distances within cluster, right? And I'm going to show you later on what happens to it. But certainly, as the number of clusters goes higher, the distances within cluster get smaller, and the distances between clusters get larger, right? But the thing is how significantly smaller the distance gets. See, we're going to look at it. Now, so what we'll do is, I'm going to do the table right now. And notice that basically what's happening is that I still have a little bit cluster 3, basically my I still have the cluster glass type 1, glass type 2, glass type 3 in the third cluster, right? I still have it here. And my first cluster is mostly glass types 5, 6, and 3, right? But here, look at this. All samples of glass type 3 are in the third cluster. It's not split anymore, right? And if I look at my sample glass type 1, all samples of glass type 1 right now are in the third cluster. You see that? Right? So basically, this is what's happening with k equals 3, and I'm going to go ahead and do the plot. Right? I just picked it. And what you need to do in a homework assignment, you need to try different k values, and you just write down what you have tried. Right? So now what I'm going to do is, I'm going to show you the plot. We're going to plot the distances within clusters, right, and between clusters. We're going to create a plot of the distances within clusters and between clusters. And let's assume that I want to try the clusters number between, I'm going to try k between 2 and 15. So what I'm going to do is I'm going to create an array, integer list, of lengths 2 to 15. I'm going to create an integer list, and here I'm going to loop through. I'm going to calculate my distance here between this distance, right? And I'm going to calculate it for centers. Here, centers equals I. So basically here, the k value is going to be an I. So this is a for loop, right? And what I'm going to do here, I'm going to run this method for I from I equal 2, 3, 4, 5, 6, and so on, up to 15. And I'm going to capture my distances in a vector called BSS. And then what I'll do is I'm going to plot it, right? And I'm going to do the same thing for the distances inside the cluster. And I'm going to plot this as well, right? So basically here I put the command lines. It's going to add to the existing plot. So let's go through it. Let's run it slowly. So first I'm just creating a variable, BSS, right? And this piece is not in a Word document. This is the first bonus for watching this video or for attending this WebEx. Right? So here is a list. It's just an empty list. It should be just an empty list. Oops, I'm looking at the wrong one. BCC, this one. It's just my list, right? 14 elements. So now what I'm going to do is I'm going to run this method in here. And do you remember it? $sign. The $sign is just going to extract the specific component. If you remember it up here, we look at the betweenness, right? Did we? Here it is. So I'm just taking this piece here, and I'm going to store it in a vector right here, right? So I'm going to run this piece here, right? And basically, BSS of I. So if I type my BSS right here, right now, let's see what's here. See? So here I capture the distances, right? The first element is still 0 because, well, I did not calculate for one cluster because it does not make sense, right? One cluster does not make sense. So now what I'm going to do is I'm going to plot this. So this is distances between. There we go. Right, so I plotted this. Notice that the distances between clusters gets bigger, right? It gets bigger. But let's look at the plot. Look at this. It's converging, right? So to speak. At some point, how big does it get bigger? See this? At some point, this graph has sort of like an elbow, so to speak. There is a turn, right? See that? At some point, the increase gets, so to speak, less significant, right? And let's look at the withinness now. So this is blank vector. So what I'm going to do is it's going to run this method and it's going to capture the distances within clusters. Now see this? And now it's blank, but I need to run this, right? I need to run this. I did not run it, right? And I'm not sure what's going on, but oops, I did something wrong here. Oh, because I see what I did. I just initialized it. I did not run the method. I see what I did. Now let's run this command here. Sorry. So here this is gonna run this method and it's gonna store the within this, right? So now I have to do this. I have to do WSS. There we go. So here are my distances within clusters, right? So as the number of clusters gets larger, the distances are gonna get smaller. And the graph is going to have an elbow, right? So let's do this. Let's do this here. Run. Note this here. The graph has an elbow right here. If I zoom in, I'm not sure. But anyways, look at this. This is an elbow right here, right? So I'm not sure what happened, but usually I was expecting the smooth line. But anyhow, let's look at it. See this? It goes like this. Right, and well, the reason it's 0 is because I did not look at k equals 0. I did not look at k equals 1 rather, right? So here it is. I'm starting from 2, and it significantly drops, and then it starts dropping slower. That's where the 3 comes from. I just picked it because I just thought that, well, here it's dropping quickly, and here it's kind of like start dropping slower. Somehow I have to pick an optimal value. There is no right or wrong answer, but the goal is to minimize the distance inside, the distances between the instances in the cluster center, and maximize the distance between an instance and other cluster centers. In the same time, see what happens when k approaches the number of samples. Does it make sense? It doesn't make sense to have one sample in each cluster, right? It totally does not make sense. So we want the k to be less than the number of samples. Definitely, right? But sometimes it takes a little bit of playing around. So this is one, so to speak, downside of this method implementation, because you need to specify the k value. We cannot say, hey, method, please run and select the base k value for me. I have to go ahead and keep trying, right? And there is no right or wrong answer, but the answer that you write should make sense, right? So I'll close this out. So this was the first bonus. Now we're going to go through the next bonus. And this bonus is for undivided attention while attending this meeting or while watching a WebEx, right, recording. Now, here it's going to use the library called AFPC. You're going to need to install this package. And remember the command install packages, right? And since I already installed the package, I need to load the library. Run. So there we go, and it's going to load my library. Now what I'm going to do, the method is called PAMK, right? So what I want to do is, and I would recommend you to do this, right? I would recommend you to just run this and see what the method does. So I'm going to leave this up to you to go ahead and to read this. And what I'm going to do is, I'm just going to specify the data set, which is new glass. It's a copy of the glass. I'm not going to specify how many clusters I want. And I'm going to store it in a variable. I'm just going to call it best. Right? And you'll see why I just came up with this name. So now I'm going to do this. I'm going to just run, right? And it's stored in a variable best, and I'm going to display it best. See this? NC, number of clusters is 3. The method just decided that 3 is an optimal number, right? So I'm just using this method where you don't specify the k value, and you can read more about the method implementation, but my point here is that we have different implementations of the same method, right? The same method might have different implementations in R, but the implementations could be slightly different. But see this, it says the number of clusters is estimated, right? The method is trying to find the optimum number of clusters for me, right? So this is what it's doing. I don't need to specify the k value. And now here, notice that this is basically showing me the components of the output, and including the cluster centers and so on. And if you notice that here, it's also giving me the cluster centers, but here it is, it's no longer a point. It picked an instance, right? The center is one of my glass samples, and this one, it's giving me the ID. So glass sample number 149 is the first center. See this? This is a glass sample, and it's telling me the number. And here, these are the values, right? So because if you look up the instance number 149, you should see these values, right? So it picked the instance rather than the mean. It's picking the instance number. See this? Midoids, right? And I have 3 centers here, and here is my clustering vector, right? So that's basically what it's doing. And what you could do is, although it's not required, but it could add value, not to the assignment, but if you're doing not to the exercise, but when you do an assignment, I think it could add value if you look at the alternative implementation, if you like, right? If you like, this is going to add value to your assignment. It's not required, but I'm just giving you some ideas, right? So basically, this clustering implementation picked number of k for me. I did not specify. And what you could do here is just again how to see the different components of it. And if you notice that the output best is a list. This is a list, because if I type this, right? If I type, see this? This is a list variable, and the list contains 3 components: PM object, and an NCC, and this. Those 3 are the components, right? And each, see this? If I do this, if I select just this, it's showing me the clustering vector. So those are the subcomponents. See this? Midoids or cluster centers, clustering vector, and all of this are the subcomponents, right? So remember, this is a list. In order to see each component individually, this is a little different. So what I have to do here, you have to do it in the double brackets. I'll show you. So for instance, if I'm not, okay, let's see this. If I'm interested to see just the clustering object, right, there's the clustering, I have to put in a single bracket. That's what I'm doing here. I'm going to run this, right? So this is showing me just the clustering vector. Why did I put it in the brackets? Because if I take check the attribute type, the variable type here, right? If I check the variable type, this is giving me, oops, let's look at it right here. See this? If I check this here, I see that I have the components, right? This is a list, and the list contains of the several components. And what I want to do is, if I want to see just the clustering part, just part of it, I have to put in a bracket, because that's a list here, right? And I could do this. I could do these names, this, try this, and it's gonna give me, see this, that's a list, right? And those are the components of this is a sublist, so to speak, a subvector itself. See this, those are the components. So that's why I have to put a bracket, because it's a subcomponent. And here to see just the clustering info, that's how I do it. Now, here, this is a tricky part. This is a little tricky part in terms of R. I want to compare my cluster with the actual glass type. Now, here I have to put the double brackets. I have to put the double brackets to get this part. In order to pull this part right here, I have to put in the double brackets. Because, see this, I have this. See, best is a variable that stores my output. This piece here is a component of the best variable, right? And what is best? Best, what is this PEM object? It contains the elements, right? So this part is an element of an element, so to speak. So I have to put double brackets just to put the cluster, just to pull the cluster number. And here is a glass type from original data set, right? And I'm going to run this. Take a look at it. What did it do? Here, see this? Almost something similar to what I had before. It put all instances from the glass sample 1, it put in the first cluster, right? So this is clear, first and third. Sample 1, sample 3 is clear, right? So basically that's what it's doing, and most of the type 7 is in the third cluster, right? So it's still a little bit not clear, cluster 2. Well, but what you could do is you could play around with different K values, but if you saw it, the number of glass types is not necessarily the best K value in here, because we don't care about the class, right? Well, I just care to check. I just care for comparison here, but in general, to run the clustering, it's an unsupervised method. We don't know, we don't have a class label. We want to group the instances based on the similarities. So I want to group my glass samples based on the chemical compound. And each glass sample does not have a label on it, right? Now here, there is another method here. So this is a cluster plot, same method as we did before, right? So I'm plotting my 3 clusters. And here, this is another method. This is another method that you could use. And you just, I just want to plot my, I only want to plot the clusters, basically, that's all. But the thing is, here, I have to use double brackets, right? You have to use double brackets if you are trying to extract component of component here, right? So that's something to keep in mind. And if you want to learn more what this function is doing, you need to type the question mark and do this, right? Now here it's part of the FPC package, right? So you need to make sure that FPC package is loaded in the memory, right? You may have it installed, but it also needs to be in the memory. Just keep it in mind, right? So some of you asked me about the outliers. For this specific exercise, do not worry about it, all right? For this specific exercise, do not worry about the outliers. But in general, the outlier would be the glass sample, perhaps, that has unusual amount of certain elements, right? So if you look at it here, for example, this is my aluminum, right? Suppose that I have a glass sample that has 100. That's going to be considered an outlier, right? But for this exercise, let's just not worry about it. But in general, you would probably want to handle. But one person asked me if we handle it before scaling. There is no right or wrong answer, right? So a lot of questions that I see are open-ended. There is no right or wrong answer here, right? So that's one question I received. Another question I received, the interpretation of the cluster centers. So think about it as some type of, if you use the k-means implementation, cluster center is some kind of like a point, right? It's some kind of like a point. and it has multiple coordinates. Just think of it this way, all right? So I realize it's difficult to picture in multiple dimensions, so that's why I kind of like did a simplified picture in 2 dimensions, so it's much easier to understand, right? So basically, if you remember it, we were looking at the output here, back up, it was giving me the instance number. So just to make sure you want to compare, right? Let's see if it matches 149, right? I would have to scroll all the way because, oops, it should, oh, I see what's happening. I should be looking at my cluster because I scaled it, right? I should be looking at my cluster instead. I mean, I'm sorry, view, my glass. Right? Because basically what I did was I created, new glass. What I did was here I created a copy, right? So I should be looking at the copy view. Now we have to remember that it's case sensitive and we need to remember how to spell. Sometimes we need to remember how to spell. Okay? Now there we go. So here it is, right? And I'm gonna scroll down just to make sure. Yeah, so you're gonna scroll down and then scroll up, right? You just want to just to make sure. Scroll up 149. Yeah? Yes, so it just, yes. You see this? It seems too much. Yeah, so here this method, it picked the instance, right? It's showing me the instance number. See this? This is a different implementation. I have an instance number rather than the point in the space, right? It picked an instance or glass samples at the cluster center. This is a different implementation, and it's gonna add value to your paper if you want to do that. I think it's gonna add value, right? And if you find additional clustering implementations, you're more than welcome to look at it. You're encouraged to look at it, right? That's my favorite part about R. There is more than one implementation of the method, right? So at this point, let's see what questions we have. And if you may have worked with me for some time, you may have realized that I like questions, right? So I really love questions, and I love when students ask questions because it shows me that everybody is participating, everybody is paying undivided attention, right? And can you explain the scale? Sure. So now this is what we do is, when we're not sure what the method does, we're going to do question mark, right? And we're going to look at the help page. So basically, what we want to do is, if you notice that in the original glass, right, some variables have a bigger value range. We want to standardize it. Look at this silicon element. My numbers go up to 72, right? Here, it's almost 0. You see that? I have a different value ranges, so somehow I want to standardize it. And you have 2 input parameters, right? So basically, if I set center equals true, it's just gonna set my mean to 0, right? So what I can look at it, I can set the center, I can set equal centers, right? And I can also rescale it. And it's because, see, the problem is, see this? My value range in here is, see this? I have to run the summary command just to show you this. If I run the summary command on the glass, right? See this? See how big the gap is? See, here is the small, the barium, I have the difference just 3, right? Here I have 0.5. On the other hand, I have 75. I'll be required to use the R packages? Well, you need to load for the homework assignment, you need to load the first one. Yes, you do need to load the cluster, because you won't be able to plot. You won't be able to do the cluster plot if you don't load this package. So this one is compulsory. The other one is, well, up to you if you want to do it in an assignment. If you want to try to implementations, you're more than welcome to. It's going to add value to your assignment if you try. But for the exercise, just stay with this one. You need to load cluster, right? So here, notice that the range is different, right? So I have to some kind of like standardize. Because if the range is different, how am I going to look at my distances? How am I going to do that? So look at this. If I look at this, let's run the summary on the new class, right? New class. You see that it's more like standardized. I don't have the big difference, right? It's approximately. I cannot say the same, but it's approximately. Yeah. Because I don't have any more like 70 or something. I hope I addressed the question. So let me see. I have to open the chart because I don't see it right away. Okay. How did we determine? Okay, I think I may have answered it. Okay. So how did we determine the number of clusters to create? Well, we play around, right? There are many methods we use. We can just see what happens, right? You can try different numbers, and you can look at the sum of square distances, right? And if you want to, you can do the plot the way I did, but it's not required, but it's gonna add value to the assignment. Now, how did I came to the 2 through 15? Oh, this is an excellent question. How did I do? Just random. I just decided to do 2 through 15. Just came to my head. I could do up to 20. I could do up to 30. But I kind of like looked, how many instances do I have? And then I just decided. It's just my decision. There is no right or wrong answer. It was just my choice. Can you use best? Oh, let's try this. So somebody asked me if I could do. Okay, let's see this. We cannot just. Somebody asked me if I could do this right here. Let's see. Yeah, excellent. See this? It worked. So basically, this is my favorite part about R. There is more than one way to do the same task, right? So earlier I was showing how I would have done it, right? I had this class info in the brackets, right? But one of the meeting's participants suggested this approach is excellent. So this is another way to do it. So I had it down here, right? Class info. What I'm gonna do is I'm gonna post it here. I'm gonna put it here, right? And then when you get a copy of this script, I'm gonna have it both ways. So thank you very much, Danny, right? Danny, thank you very much. I really appreciate it because this is gonna add value to this script, right? And this is an alternative way to do it, so I'm gonna have it here, right? I'm gonna add this. Now let's go down. Scale method, right? So we just discussed it. Let me know, Danny, let me know if I did not address it, if I did not address this question. Ayo is asking, are we required to use these packages that I use? Well, you need to use the cluster because I asked you to plot, right? So you have to use this package because the implementation of the clustering plot method is in this package. So you need to install it and you need to load it in memory, right? You have to do that, like I'm doing it here. Yeah, but it's gonna be different directory if you are Mac, right? I have Windows 10, but on Mac it's gonna be a different folder. But if you're not sure, what you could do is you could just go in here to the packages window, and you're gonna find it, and you're gonna click the checkbox in here. If you click the checkbox, then R is gonna run it on your behalf, right? R is gonna run the command on your behalf, and somehow it got unchecked. Let me check it. Okay, so I got checked, right? And the R runs this command for me on the behalf, right? Now, so center is true. Yes, center is true. It's gonna move mean to the 0. That's right. It's gonna do it for all variables. It's because I put as an input, I use my data frame. I did not specify the individual variable as an input. I put the whole data frame, right? If you see it, if I scroll down here, if you see it here, yes, I put the whole data frame, right? And another thing to keep in mind, it's a shortcut. T is the same as true, F is the same as false, right? So now, yeah. So what does the scale do? So scale is basically going to, so let's go back to the help page, and this is here. So scale is just gonna be rescaling the length, so to speak, right? Equal to the number of columns of X. So center, this is the center, and scale is gonna look at the standard deviation. That's what it basically does, right? Okay, so that's going to be looking at the standard deviation here. See, so basically if you look at this here. Now, another thing is that you want to make sure that you handle your missing values, but see this, if the scale is true, then scaling is done by dividing the centered column by their standard deviation. See this? So it's going to be using the standard deviation, right, to scale it. I did not select it for this data, but again, there is no right or wrong. There is no right or wrong. Oh, here it is. Pay attention to this, NARM. Well, basically, it's telling to ignore the missing values, right? It's telling to ignore, but you want to handle the missing values, right? And I think someone also asked me, on a homework assignment, there is a question, list any additional data pre-processing that you did. If you did not do anything additional, then just write none. None is a valid answer, right? None is a valid answer. So if you did not do anything in addition to removing the unique identifier if there is one, right? Removing the variable, vehicle class, I believe, right? In this case, it's the class type, yeah. So if none's unknown. Now, question. Does the mean algorithm internally use some kind of, can we try it without scaling? Sure, you can try it without scaling. Sure. So let's go ahead and try it, right? So I call it customer service, right? That's my terminology. So if I'm asked to try it, let's go ahead and try it. So what I'm gonna do is I'm gonna do this again, run, new class, and I'm gonna remove, I'm gonna do this, but I'm not gonna do the scale, right? I can try that and see what happens, right? So I just did this, right? I can go ahead and do it. Sure. Centers. Right, but see this, I did not scale it, right? So now let's see what's gonna happen when the time comes. Let me visualize it. Let's see. Let me visualize it. Well, it all depends on example, of course, but let's see. Let's do this one. Oops, come on. Did I run it? No. Run. Okay. So see this? In this case, it doesn't really show much difference, but it depends on the data set, right? In the data set that you have for the homework assignment, it did not look really well, but without scaling, trust me. So, cluster plot, and it's a little bit harder to read, of course. Oh, you can zoom in, right? It depends on the data set, right? It depends on the data set. In this case, it still worked. But you do want to scale when you do the clustering. You do want to scale it, right? So here it is. And now let me try this k equals 3. I can sure go ahead and run it, no problem. Yeah. And I can try this one here too. Oh, but now, let's see if I get the same result. Yeah, looks the same for now. Now I'm gonna do this one again. Test. Well, it's still giving me 3, but probably my distances are gonna be different, right? I think my distances are gonna be different. That's what's gonna happen. Run. Right? And see this? I have a different cluster in the center now. You see that this is different. I'm sorry, the size is different. I'm sorry. I should be looking at the center. I'm sorry. Centers. Let me see the centers. Oops. Let's do this. Now, let's look at the centers. I think my centers should be different. It's expected. Oh, no. The first one is the same, right? So anyway, it all depends on the data set, but in a homework assignment data set, if it's not scaled, try it and you'll see what's going to happen. Now do this. And here is the plot. Yeah. In this case, it did not make much difference, but in general, you need to scale. So let's see. This is you see this? The distance is going to be different. The sum of squared. Yep. So basically, make sure that you scale it, right? And make sure that you remove the class variable because this is not classification, right? And you remove unique identifier. Yes, I tried it without scaling. And in this case, it did not make much difference, but on some data set it does. If the value ranges if the difference between value ranges is bigger. Now, let's see what else we have. Scrolling down. When we should use the scale equals true. That's also a good question. There is no right or wrong. I can use it. I can go ahead and use it. Sure. Right. So let's go ahead and do this. And let's set it back to F because that's what I want you to have. Right? So let's see what's going to happen. Let's just go ahead and see. So far so good, right? But when I ran the best method, you'll see what I got. I'll see what I got in a second. So here I'm still looking at the k-means implementation. Now you'll see something. See this? My elbow is now in a different point. Now, see this? It's changed. The elbow location has changed. You see it? It's totally different now. The distances are totally different now than what I had before. Now, let's see here. Let's see what this gives me now. 2. See, this is different now. It's giving me 2. It does not really see much difference, right? So the output is different. It's not the same, but there is no right or wrong again. But what you need to do is you just need to interpret the result, right? So here it just put the instances into two clusters. Yeah. So that's basically, it's different. I'm not getting the same result, but does it really make sense? Take a look at it. Does it make sense? That's why I did not go with this option. That's why I set it to false, because I took a look at it. I said, no, it does not make sense. Why do I have to have 183 in one and 31 in the other? I just did not like it. That's why. Yeah. I picked it this way because I tried it both ways and I just did not like it. But again, there is no right or wrong answer. And it's a trial and error. A lot of it you need to try, see what happens, and then explain why you went with the choice. Right? Now, please let everyone ask their questions to everyone. Oh, well, okay, this is what I'm gonna do. I'm gonna be reading, yes, that's an excellent request. What I'll do is, I'm gonna read the question, right? I'm gonna read the question in the chat and answer, because the problem is if I unmute everybody, they're gonna have a lot of echo, and it's not gonna do much good, trust me. Now, okay, 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 somebody says thank you, you're the most welcome. Okay, so Ayo asked me why did I pick 1, 2, 3, 4. Well, you can pick anything, pick your favorite number. Or you can pick 11, 18, just because today is the 18th of November. It does not matter. You can pick any number you like. So now, Kyle. So is scaling part of data preparation phase? Yes, it is. Yes, it is. So if you notice, the question is in data preprocessing, right? So this is very important to do this in order, because each question is going to lead to the next question. The questions have been strategically made in a way that each next question is built on the previous questions. So there is a strategy behind the questions in a homework assignment. So this is really important. Now, what is it? Yeah, this is a good question. 1, 2, 3, 4. Just because it's I just picked it, right? Oh, you're the most welcome. I see some thank you messages in the chat. All right. I really appreciate it, guys. I appreciate the undivided attention and excellent questions. So let's see more questions. I really love questions, and I call it a customer service because I see students as customers, right? So, questions, going once, going twice. If you don't have any more questions, then I'm gonna call it a night, and I wish everybody good luck, and I guess thank you very much for joining this evening, and we're gonna be posting the recording and the script. All right, thank you.